what we're going to do is we're going to see a few more things that you can do with strings. Strings, because they basically represent text. I guess I should turn off my chats. Luckily, you don't understand this language, I hope. Maybe some of you do. Although nothing controversial was written. So strings, they appear everywhere because they're part of text, and that's how humans communicate. So you're going to be needing them a lot. That's why Python actually provides lots of wonderful functions that are already there, predefined for you. And in fact, one of those that I call the hammer, which is it has a really nice operator that do actually some serious work for you. Although it looks like it's a one operation, it's actually many operations behind the scene, and in is one of them. So we're going to see that today. So we're going to see a little bit of more, not really advanced, but what are the other tools that that are already there in Python provided for you to do with the strings. What you have already seen, for example, here, you create two strings, S is a rock, T is a climbing. You have seen, for example, that you can glue those two strings into a new string by using a plus operator. So basically, you can concatenate them. You have also seen something that is not common in other programming languages, which is that you can multiply a string by an integer, and that creates a new string where the original string is repeated that many times. For example, here we see 5 times S, and S is a rock. 5 times S, you get rock repeated 5 times. So you have seen that. I also believe you've seen len of S. Len is a built-in function in Python. If you give it any sequence, and it doesn't have to be a sequence of characters, like a list, for example, is also a sequence, it's going to give you the length of that sequence. In other words, it's going to give you the number of elements in that sequence. If the sequence is a string, it's going to give you a number of characters in the string. All right? So this is what you have seen. What you haven't seen is this in operator that we heard at the beginning. It's a really powerful thing that is built in Python. It basically does a search. And it's also part of the for loops and so on. So for example, what it's asking here, if S is your string, it's asking if whatever is in X, let's say X is a substring, it's asking, is this substring in S? Okay? So for example, here it's asking, is O in S? All right. So what is S? S is a rock, and then you get a true. All right. But, so let's see. So this is when it comes to in, and you can also ask not in. You're asking, is this string not in there? But, so now we're going to go to idle. But in fact, I forgot something else that I wanted to cover at the beginning of the class before we continue with the strings, because we're going to actually do loops and for the first time see, because strings have more than one character, so it's a natural place that you can actually loop over the elements of a string. But before that, I wanted to make sure that it's understood, because you're writing functions for your assignment, or in general, the whole course will be about breaking problems into subproblems, and these subproblems you will write as functions that you can reuse. Let's pause what I started for a moment, and you tell me, what does this print? Because I also want to show you something else. You don't have to tell me. So everybody for themselves, please look at that piece of code and answer question number 1 for yourselves, is what does the following program print? So take, I don't know, half a minute and get the answer for yourself. There is nothing tricky in this. It's just for yourself, you're trying to understand if you know how function calls work. Okay, so hopefully you have some answer. And let's see what we have here. We get that it prints 6. But much more importantly than this is to understand exactly how Python runs a program like this and what is happening in the memory when a function starts running. Okay, so this Python visualizer tool, again, it's a wonderful tool to to learn this, to see exactly what is happening as the program runs, and it's something that is critically important to understand. In addition, this will be super useful when we come to recursion, for example, because there the function calls are less intuitive and students can struggle more. But not students, I mean, in general, it's a concept that many struggle with. Okay, so let's run this one. So first thing to observe is that in general, a function, this is a function definition. Here you are just designing a function. The thing that I highlighted is dead code. It's not running, it's not in memory unless somebody calls it. Okay, so when you start running a program, so let's do visualize execution. Is this too tiny? Can you see it? Okay, so the program always starts at the beginning. Okay, so the first line, the red line, remember, tells you what will be the next line that is going to get executed. So Python in this line is going to learn the same way as if the first line was x is equal to 3. Python learns that you want to have a variable called 3 and you're going to assign some value to it. This way, when you execute this line, Python kind of is learning that there is a function with this name. It's like you're defining a function of that name. So what will be the next line to be executed? So remember, the red line will move to the next line that the program will execute. So where will the red line move? Sorry? I can't hear. You have to speak up. Just a number. That we have 1 to 11 lines. The red line will move to one of these numbers, 1 to 11. Which one? 5. Exactly. So this is what is very important. You are not going to run this function. Nobody called it. It's a dead code. And besides, how would you run it? You come here, you need to do x plus y plus z, but nobody gave you those values. All right? So Python moves to the next line. You see what is the next line? It's what's lined up with this thing here. And you see here it makes a note that there is a function called add3. And here, similarly, it makes a note that there is a function called times3. So in case somebody calls it, it's not going to give you a mistake. I don't know what times3 is. All right. So another thing to know is that, and it's actually explicit in some other languages, is that the program always starts in the first line. And somehow the program itself, you can think of it as being a main function. It's a main thing running, okay? And this is the case in other languages. You have to actually explicitly create a main function. This is where the program starts. In other languages, when the program starts, it's looking for a function called main, and it then goes into that function and starts the program there. In Python, you don't have to do it by default. It's kind of the first line, and the leftmost edge, you find that line, that's a main, that's where the program starts. So when you hit run, the main starts running, okay? So far, you were running this line and this line of the main. Okay, so where is the red line going to move next? Give me a number. 9. Not really 9, because 9 is commented out, but 10, okay? So we get to line 10, Python executed these 2 lines and learned that these 2 functions. So here, on the left-hand side, what I was calling a main, the thing that is on the left-hand side, this rectangle here that is colored blue, this is what Python is currently running. It doesn't call it main, it's using another fancy word, it calls it global frame. But this global frame is your main program. It's running. What is blue, the blue square is currently your program running. The main is running. Okay. So here we come to this line. On the right-hand side, we have a function call. It's calling a function times3 and sending value 2. So the red line will move to which line next? There are 2 things to understand here. First of all, where will the red line, and that's going to tell you what will Python execute next. So where will the red line move next? Exactly. So it's going to be, because we are making this function call. So observe 2 things. We are sending value 2 to W. All right. So first thing to observe is when I click forward, that this main program is going to turn gray. That means that, at least in this thing, that the main pauses. It has to pause, because the thing that main is required to do is to assign whatever this function returns it to this variable blah. Well, it cannot assign anything to blah until it gets that. So the main pauses, and this function here starts running. That's what I mean, it's dead. This function here is dead, doesn't do anything. It's not executed until somebody calls it. So look what happens. We do forward. The main here is now white. It's pausing. It's waiting in this line here for this function to complete. This function times 3 starts running. So it's only ever one function that is running. This function here is running. First thing that gets executed in every function is you take a parameter and make it equal to the value that the user sent you when they make a call. So the first thing that does get executed is w is equal to 2. You put 2 in w, so w is equal to 2 is executed whether you want it or not. And you can actually see it because inside of this function that is running now, variable w, and now you see the parameter is just really a variable, gets created, and 2 is assigned to it. Okay? So when we do next, what's going to be, where is the red line going to go? Sorry? Where is it going to go? 11? It's this function here that now needs to be executed. We only executed the first line of this function, 6. We made a call. Now your function is actually running. So you go to line 6 and execute this line here. Okay. We look at the right-hand side. Whatever this function call here returns, it has to be assigned to variable p. Okay, so on the right-hand side, we have a function call. What is w? W, this is running, and w is 2. So this is the same as add 3, 2, 2, 2. Okay, so where is the red line going to move now? Sorry? 7. Okay. Here we have a function call. So that means this function has to start running. Okay? So this function is here. So this one here has to pause. It needs to wait for the function. Okay? So this one is paused, and we execute this function. We had the call add 3, 2, 2, 2. Therefore, x is equal to is executed, y is equal to is executed, z is equal to is executed. So therefore, we have 3 variables. This function is main is paused, 3 times function is paused, and a function add 3 is running. And we have 3 variables, x is 2, y is 2, z is 2. Okay, what's the next one? Next line. Exactly. So this function is running, so we go to line 2. This we now can execute. 2 plus 2 plus 2 is 6. It gets assigned to variable t. Variable t doesn't exist yet, so it gets created. 6 is put in there. And now return. I know that for some students this is confusing, the return. So here, please observe a few things. This function is now going to return value 6. First thing, whom will it return? In which line? So the program is now currently running this. It's going to return 6. Whom will it return that value 6? And what will be the next line to be executed? Who called this function? Who called add 3? Sorry? Yes, exactly. So remember here, times 3 was waiting here. So it was times 3 that called this, and it's waiting over here. Okay? So when this function returns the value, then this function can resume. Times 3 can resume. So that's what you have to keep track of. Function add 3 returns the value 6. Whom does it return it? Well, to the caller. Here's the caller. 6 will be returned here, so you can finally put 6 into P. There's no more waiting. This function can resume. But number 2, you can see what I was trying to tell you previously, which is that, what I mentioned in previous classes. The moment return is executed, the function disappears. It stops running. Okay, you will see now that the blue thing disappears, and it gives back the control to the caller. The caller was that function. So we go forward. There you go. This function was waiting, but it doesn't need to wait anymore because value 6 was returned finally. It can assign 6 to P, and now it needs to return P, that is 6 to whom. So this function here returns value 6 to whom? Not to blah blah is a variable, but to the main, right? To the what they call global frame. Global frame or the main was waiting over here, in this line for that value. So when we move forward, we will see first thing that this function terminates. It's not there anymore. The main resumes, and finally 6 can be, main was waiting over here, so 6 was assigned to blah, and then we can finally move to the last line, and 6 gets printed when we do forward. Okay? So I hope you see, even for those who programmed before, this type of picture and clarity may not have been there. So it's a very important tool to play with and understand what's going on. And just one last example, really, again, your program design, your function design or function definition is really a dead code until somebody calls it. And of course, you can call it as many times as possible. But each one of these calls is a separate process that gets run. For example, here we can do something like, okay, after that, I want to do Q is equal to, I don't know, 3, W plus 1, 11. Okay? And then you do return P plus Q. I don't know. It can be like that. Okay, so if we run this, the beginning is exactly the same. You learn this. We have this function starts running. Okay, so this is all the same. This one is now waiting in 6. It's waiting in this call where we sent W is 222. That one is running. Add 3, 222 is running currently, as you can see here. So that's exactly the same. When it returns value 6 here, and 6 is assigned to P. But now we come to the next one, we have a new call. So the same function definition starts running again, but with different parameter. You need it for something else, to compute some other values. So when I do forward, you see this function starts running again, but this time it values where x is 3, w is 2 plus 1 is 3, and z is 11. Okay? So it keeps on running like before, returns value here. And finally, we can do this line, P plus Q is whatever that is, 23, and returns 23, and then it prints 23. Are there questions about this? Okay, if any of this was too fast, please do it by yourself, and please make sure you understand this, because this type of things with time only get more complex, in particular when we get to recursion. Okay, it's critical to understand how functions run. No questions? Okay, so let's go back to strings and see examples of some of those things that I mentioned. Okay. So I want shell. Okay, so what did I have here, for example? All right, so let's create a string. So S is a string. S is a variable that contains the string, and you have seen this operator in. In this case, it's asking is E in S, and indeed it is. In fact, a couple of E's are there. What about this? This is false. Python is case sensitive. While we have SEP, we have a SEP with a capital S. So this is, while this is true, the one with the lowercase s, it's not true. What about this? What do we get here? We get false, because actually this in function, in case it's looking for exactly the match. You're asking, is substring SP, is exact sequence, is it there? It's not. S is there and P is there, but SP, a substring, is not there, so you get a false, right? So you're asking for exact substring in a string. Okay, so what about this one? Yes, because in this sentence we have two empty spacings. What about this? This thing here is an empty string. Is empty string in S? Here's your S. Okay, so yeah, so usually I get false, but actually it's true. And the reason actually, again, for this convention, actually it's not even a convention, it goes back to math. empty set is a subset of every set. Okay, so empty set is a substring of every string. Okay, so you get true. Okay, what about this? Yeah, this is false because sept is in S. What about this? Well, this should be easy, right? This is true because word OCT is not, string OCT is not in S, so that's true. Okay, so here's one of the most important things, and I mean, it appears in all programming. It's something called indexing, and it's actually what leads us to the loop, although for the first type of loop that we're going to see, you don't even need indices. But the point is, let's look at this string. Let me clear the screen because I want to, it's a little bit of like a new topic. Okay, so if you look at the string, remember the definition of the string. It says that it's a sequence of characters. It's very important the word is a sequence because it implies there is some ordering of characters. And it makes sense because strings, really the order is important. If you take a sentence and if you randomly permute the letters, you're going to get something completely different. So for the things where order is important, this is called sequences. And it's only for sequences that it makes sense to tell me, give me the first character or fifth character, right? If it's not a sequence, if there is no order, there is no such a thing. You may think, but well, everything, I can ask, give me a fifth and sixth, but it's actually not true. There are objects that are very useful, such as sets, that are not sequences. They don't have order. You've studied sets in math. There's a reason they're represented like this. They can have something like have number 1, number 10, I don't know, word blah. This is a set, okay? And it's not because I use this, okay? This is a set, and elements of the set are not ordered, okay? So you can have another set. And the reason is that for many applications, you would use set, you can do things much quicker on the sets. And you would use sets is, let's say, all you want to know is I give you two things. I want to know if they have an element in common. So you want to do intersection fast. So the order is not important. So if you have a data type that is a set, you may want to be doing things like, okay, tell me if 10 is a set, or I give you two sets, you tell me if their intersection is empty or they have something in intersection. Okay? So sets by nature are not ordered, but strings, and we're going to see lists next, they are ordered. Because they are ordered, it makes sense to ask, give me first element, second element, and so forth. Right? So because of that, you can ask, okay, give me the first letter of the string. The way you do it, the syntax is you give it first the name of the string, you open square brackets, and then you give the position of the letter that you want. Okay? So let's say I want a first letter of my string. You would think it's this, right? But it's not. And the reason is that for historical reason, counting in programming or with computers starts at 0. Okay? While even though when you do len of S, that's 15, you count when you start counting, you're not going to start counting at 0. You're going to start first letter. There's 15 characters in that string. But when you look at the positions, the first position is called position 0. The second position is called position 1, and so on. So if you really want a first position, you're going to use 0, and it's going to give you I. How do I get the last position? So this string has length 15, and I want to know the last letter. What should I put here? Exactly. It's very important to realize that it's going to be the length of the string minus 1, because if you start counting at 0, this is 0, this last thing will be at 14 for this particular string. But, I mean, let's say that you don't know exactly what is the length of the string, and I ask you, how do you get the last element of the string? What would you put there? Last letter of the string. And you don't know it's, in this case that it was 14. You don't want it hard-coded. How do you get that?
S dot lane. Lane S. Lane S minus 1.
Exactly. So we know that we can get the length of the string by asking len of s, but remember, len of s is, in our case, is 15. So if you ask len of s, it's going to crash because when you start counting at 0, len of s position is 1 after the last, okay? And then Python gives you string index out of range. It's one of the most common errors. It's so common that it even has a name. It's called off by 1 error, that you forgot to subtract 1 because position starts at 0. So the last element is that position len of s minus 1. Okay. Python has something very nice, actually. And I don't know, I haven't seen it in other programming languages. It allows you actually to use negative indexes. So if you want, you can go from the back, but then you use a minus. And so s of minus 1, it gives you also the last, the last character. So if you want to go from the back, you just use minus index. Minus 1 position, minus 2, minus 3, and so forth. So why do you think from the back we are starting with 1 and from the front we are starting with 0? Yeah? Exactly. It makes sense, but minus 0 is 0. So you would end up starting from the front, right? So there is a reason, exactly. So in some ways, you're right, it doesn't make even sense because 0 is neither negative or positive, okay? All right, so this is really nice. I thought it was cool first time I saw that. So let's say that, let's say I want to get the first character of a string, but using a negative index. What should I put? In terms of general one, not hard-coded, not hard-coded numbers. Yeah? Did you raise your hand?
Minus.
No, I want a first element. I mean, look at this. Let's go here. If this is minus 1, let me demonstrate. S of minus 2, let's remember what S is. So we go from the back. Minus 1 is R. Minus 2 is E. Minus 3 is B. So how do I get, with that negative index, how do I get the first one? Exactly. Okay, so we do minus len of S. And this one, we don't have that minus power, in fact, plus 1, because we started counting at 1. Okay, so you're going to get that first, character. Okay, so this actually brings us to something very important. Not very important. It's a super powerful tool in Python, and as far as I know, it doesn't exist in other languages unless they edit it in the meantime. Java, C, and things like this. Okay, and it is slicing. So basically, when you do something like this, S of 3, you are asking, give me an element that is in position 3. So you're giving just one position. Python allows you to ask that you give me subsets, consecutive subsets of a string, not just one position. You can say, give me everything from position 2 to 10. It's called slicing. And it's extremely helpful. Things later on when we get to solving some real problems like a merge sort and binary search, things are much easier to code. In fact, some of the things that I wasn't able to do before when I was teaching Java, I can now actually teach it. I can teach it, but I couldn't really code it. It was too painful to code. Now you can code, thanks to slicing, you can code it in Python in maybe 3-4 lines of code. Okay, but we're going to get to that later. So here it's very simple to use. So let's see, we have this string S, and here's the syntax. So you have seen if you open square brackets and you give just one number, it's going to give you a character at that number. But if you give it, okay, if you give it two numbers separated by a colon, okay, it's going to give you a string that starts at position 3, so it starts at the first integer you give it, and ends in the last, except it doesn't take that last character, so it's up to 7th position. Okay, it's very important to understand this. So in a math notation, that would mean you are giving a range. What do you want? A range of position. and it includes the first number, okay, and it goes up to the second number. It doesn't include the letter on the, a letter on the last number, okay? So what do we get here? We have start at position 3 and go up to 7. What will this create? Okay, let's just press and see. Position 3, 0, 1, 2, 3. It starts at this first number. That's 3. That's I. Then this is 4. This is 5. This is 6. So it's doing all of that. This is 7. So it doesn't do that one because it's up to 7. Okay, so this creates a string, a substring that of this string starting with position 3 and going up to position 7. Something that you need very often is our substrings that start at the very beginning and go up to some value. Okay, so this is so common that there is a shortcut. So if you wanted something like this, let's say go from the 0, start at 0 and go all the way up to 7th position. If your first number is 0, meaning you want to start at the beginning, you can actually omit it. So there is a shortcut. This is the same. Okay? If it's not there, if you see a semicolon but the first number is not there, that means starts at the beginning. Okay? So what about this? What do you think this does? Sorry? Exactly. That means starts at 7 and go to the end. Okay? So this is position 7 and you go to the end. All right, what about, so which is basically equivalent, do you think it's equivalent to this? Yes, no? No. Why not? It's up to, so it's actually not giving you the last one. So if you really want to spell it out, in this case, it's this, because you will not take that position, okay? So, actually, this is, in a way, more readable, because it really says start at position 7, go to the end. Okay, so what about this? What now you can guess what this does? It gives you the whole, it gives you actually, you may think, oh, why is this? Why would you do that? You have S already. But actually, it creates a copy of S. This is something you keep in mind is going to become more and more important. The slicing operation always creates a new string. It doesn't modify the original string S. Okay, so we were doing all of these slices. Look, S didn't change. When you do the slicing, it creates, remember, a Python shell shows you what happens. See, it created a new string. We could have captured it in here, and now your new string has that. So if you want a copy of your string, a separate new copy of a string, because one, I don't know, with list is going to make more sense, you can actually do, I don't know, R is equal, and now you have 2 strings, but really 2. In memory, these are 2 strings, okay? The copy of each other. All right, one last slicing example. Let's see this. We have seen that this creates, if you omit both first number and second number, first stands for the beginning, second stands for the end. What do you think this does? If I actually, so you've seen that you can use the square brackets to indicate, give 1 integer, then you're going to get 1 character, 2 integer, which indicate beginning and up to. And what do you think this does? Just to get, you don't need to know this. I'm asking you to guess based on what we've seen so far. We said if you see a colon, actually 0 is omitted there. If after the first colon you also have something new, it means, oh, well, the end of the string. This means goes from the beginning of the string to the end of the string, and then there is a third number. What can it be doing? I can tell you that if it's a 1, it's all as a before, so we are omitting it. What about if I put a 2? It's just giving you a step. By how much you're changing a position, right? So here, if you're changing it by 1, means you start here at position 0, change it by 1, that's a position 1, change it by 1, position 2. It's giving you how big of a step you make. So this one here says you're making a step of 2. It's like giving you every second character. Okay? So you start at position 0. That's an I. Then you do 0 plus 2 is 2. That's an empty space. 2 plus 2 is 4. On position 4 is S, and so on. Okay? So you can put any integer there. It's telling you this would give you every third character. Okay? So there for the slicing, they are basically, or for indexing in Python, there are basically 3 versions. One is you give it 1 integer, which is a position. The other one you give 2 integers, which is then a range, starting and ending. And the third one is you give 3 integers. First one is beginning, second one is ending, and the third one is by how much you skip. And the same thing will work with lists when we get to lists, which are called arrays in other languages. Okay, so this is important to know. Please make sure you know slicing, because really in Python it appears everywhere. And that you remember this thing that it goes up to the second number, because this is also true for the loops and so on. We'll see that. Okay, last example, and then we're going to code some problems. Okay, so here. What do you think this does? Okay, we have seen this. You start at the beginning, omitted. Go to the end. Since it's omitted, step is 2, every second one. What does this do? Beginning is omitted, so it's beginning and -1. Yeah? Yes, it gives you, it starts from the beginning, gives you copy of the string from the back, and again, this is something else that can be useful. Yeah?
You can use this to create like a decryptor, right?
It's very useful. You can use it for anything. It appears very, I mean, you can code this function yourself, right? So, okay.
You could do, like, let's say as a password.
Well, it depends.
Sending it to someone.
It depends what kind of encryption you use. If you use some silly encryption, you can encrypt it like this, but it's not so difficult to crack that one, right? So, I don't... Okay, so that's and something else actually that I think I forgot to say in another section, which is strings, another fancy word, but this one will be appearing so much. String, once you create a string, it's unchangeable. You cannot change it, and the fancy word for unchangeable is immutable. So here I'm going to demonstrate what I mean by that. We have the string S. Let me think, oh, I changed my mind. I don't want this to be a capital letter. So you may be tempted to say, and actually with list, you will see we are able to do this. Or I want this first character to be actually a character I. You're going to get a mistake because you're not allowed to change elements of the string. Okay, yeah?
Can we try the same thing except for -2?
Oh yeah, you want to get everything from the back. You should get everything from the back, but So you start with R rather than, you start with R, but then you skip, you get B and then E and so on. Okay, so these are kind of, slicing is, okay, so let's just look back. As I mentioned, and I didn't show it to you, there's so many useful functions there's so many, text is needed so much that Python has wonderful functions provided for you. Again, hammers, right? There's a lot of hammers for you that is hidden from you what they're doing, but these are very useful hammers. Let me show you a few of them. Okay, so if you look at it here, if you do dir str, remember strings are a data type of a string is an str, and if you ignore all these that start with the 2 underscores, you get some super useful functions on strings. And in fact, most of them you can guess what they're doing by just looking up at the name. But let's not do that. Let's see. Remember, if you want to know something, and it's not in a building, so you're going to start with the name of that module or name of that library. And let's say we want to know what this function lower does. Okay? So we have this string s, and it says that it returns a copy of the string where everything is a lowercase. Okay, but compare this function. There's something important here going on. Okay, so look at these help pages, the way here, this is like a type contract. And this one you call, the functions you've seen so far, like ABS, we were just calling it by name. So do you notice some difference between these two help pages? Well, this one should also have actually type contract. It should have had an arrow, say returns a number, but it doesn't. In the previous Python versions, they had a bit better type contracts written in the, but that's not what I'm looking for. Do you see a difference between the way you're told to use these two functions? Yeah?
There's the term for copy.
Is the term?
A
A copy of, that's actually very important, but that's not what I'm looking for. I'm looking for the way you use them. The copy thing, actually, please do pay attention. It's very important, actually. Yeah?
Oh, the argument, the parameter.
Yes, there are no arguments, but more importantly, this. We are looking here at this dot operator. Okay? Why is that important? Because before, we have seen, let's say we have this string s, and you say, okay, this function lower is going to give me a copy of a string, okay? It's going to give me a copy of a string, but all the characters will be lowercase character. Well, that doesn't work, okay? Because basically, so when you run a help in the future, please pay attention to two words. This one says method. First thing, help on method. This one says help on function. These, both lower and ABS, they are both functions. But functions that they call methods are kind of object-oriented functions. You call them a bit differently. You call them in object-oriented way by using this dot operator. And I'm going to show you how. But in fact, you've already seen it with Turtle. When you were doing this Turtle, you created this Alex. We called the function saying Alex dot. It meant move that object. And then you head forward or something like this. So when you look at the description of how to use it, this one is telling you you have a string and you're going to use dot operator, then a function name. Whereas with this function ABS, you just call it by the name. Okay? So if you see a method, you need a dot, you need an object, then dot, then function name. That's how you make a function call. When you have a function, you make a function call just with the function name. So S, remember, len is a function. We are calling it just with the function name. But lower, we have a string s. You use the name of that string, then dot operator, then lower. And it's showing you here that there is no input parameters. And see, it returns a copy with all the lowercase letters. And to go back to what the student said, and I'm so bad with names, I already forgot, but not you, but just the name. Actually, please pay attention to this. S did not change. S did not change. The reason is that the function lower, you have to be very careful when you're reading what it says. The function lower says it returns a copy of your given string with all lowercase letter. It does not change the original letter, and this will be different, especially when we get to lists. Because sometimes it changed the original list you're working with, sometimes it's returning a copy. So you have to pay attention, is it returning a copy, or is it changing the object that it's calling it? Okay, so lower is there. What else is helpful there? Oh, here's something that's super helpful, and I'm sure you're going to find it useful. Okay, here's one. Before I show you the super useful one, there's a function called count. It's also a method, so you call it with the dot operator. You can ask how many letters E I have here. So we have 1, 2, 3 letters E. You can ask, for example, it doesn't have to be just one character. You can ask how many times does a substring TE appear. It appears once, and so on. Okay?
If the string's name was Z, then you use Z.
Of course, you have to use, because if you have two strings, thank you, that's actually a good point. If you have another string that says, I don't know, I'm out of, so we have two strings now, and you want to use lower. Well, first of all, you have to decide which string is using it, and it's for that string that you're going to apply it. So you can do z.lower, except that everything is lower on in this case, and actually it returns the copy of z. Okay? So yes, you call it with a variable name that contains the string that you want to get a copy of with lower cases. But here's something that happens all the time when you're actually communicating with the loser. User, not loser. Okay, user. So when you're writing your programs all the time, even in the banks, everywhere, very often you're asking a question, what's your name, date of birth, you're creating an account, all of these things happen all the time. Okay, so we have seen that you can do this in Python. Let's say you can do, what is your name? Okay, and you want to store that because you want to use that somewhere. Okay, so we do that, and then you really don't always know what they're going to do. For example, I don't like when the cursor is glued to this question mark, okay? It's right there. I'm going to move away from the question mark, okay? And then I'm going to put my name. Okay, so what is stored in name? What do I get here? The point is it's not 4. And that's not what you want, right? You really want my name, and my name is not empty space, empty space, empty space, empty space, and then that, right? And you were saying, oh, why is that important? But maybe because probably later on you may want to say, okay, hello, and then you do plus, I don't know, name. You want to write a greeting, look what you get, right? It goes back again to always remember that input is going to return a string of things that you typed in. And, you know, empty space is also a character. So very often, the input that you get from the user, you want to remove what they call trailing white space from the beginning and an end, like kind of useless white space that is there. Okay, so there is a very nice function called strip. Okay, so I have this string name, and it has some white space at the beginning that I don't want. So you use it. It's also a method, right? So if you do help str strip, okay, it tells you returns a copy. Again, important, a copy of a string with leading and trailing white space removed. So if I do name dot strip, okay, you see it nicely removes the white space. And here is in particularly important that question to pay attention if it's returning a copy or changing the original thing, because probably you wanted to change this name, right? Well, it didn't change. Okay, so either you store it in a new variable, okay, you can do blah is equal name dot strip. Okay, so now blah really has, or you can reuse that because the useless one with white space, you don't need it, so you can reuse that. You can do name is equal name dot strip, and now the variable name is actually storing this shortened string. Okay, yes.
You can't change this.
Thank you, somebody asked it.
You can't delete characters from it.
Yeah, the thing is we didn't change the string. Both strings still exist, it's just that in a variable. This is something I will ask you until the end of the semester. In your head, decouple, separate completely a variable and an object. Okay? Object itself, a string I cannot change. I cannot go into the string and change a letter. Okay? This is still true. What did I do here? I didn't change a string. I have a variable. It's a bucket. Initially, what I placed in that bucket was a string, space, 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 Vita. Okay? But then in that line, I said, go to the right-hand side creates a new string, 4-letter string Vita, and it says assign that to the bucket name. So it goes there, removes whatever was that in that bucket, and puts now a new string there. So I never changed the string. I put a new string in variable. And this is easy to understand if you separate in your head variables and objects. Okay, so here's what happened. Let me draw it. First time when we run this function, okay, here, that's when variable name gets created. Remember, it's just the name of a bucket. And what was placed there is a space, 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 vida. Okay, that's what it was. And then when we did this, it was like that at the beginning. And then when we come to this line, the right-hand side creates a new string. We saw that, where you strip the white space. So the right-hand side creates a new string without the space. And then you read what it says. Remember, this is an assignment operator. It says, take whatever is created here and place it inside of this variable. Variable is just a bucket, a separate bucket. So it goes to this bucket and puts a new string that it created. In fact, that old string with space is probably still there, but not in this bucket. It's hanging there in memory. Eventually, it's going to get collected by what is called garbage collector, but we are not there yet. Okay? Okay. All right, so let's see. So we're now going to do loops, okay? In order to... So here's, by the way, so this is what we covered, because I want to show you this, because I'm going to put up these slides, that all of these at least, because these are slides from your books and they're kind of nice ones. So you can see that indexing is there, S of 0, S of 1, so on, negative indexing, S minus 1, slicing examples are there, these useful functions are there. So you should look at those useful functions. Really, you can do help on all of them. There's not that many, like 20. Again, you can guess what they're doing, okay? All right, okay, a loop. Okay, so here's how you do loops in Python. I'm going to start with the simplest loop. In fact, this loop is so simple and so nice, this kind of a loop. It's a looping over the elements that it didn't even exist in the previous languages. It didn't exist in Python and Java. They did in Java and C. The for loops were basically, as far as I know, always over the indices. But this one is so useful that they added it. I know they added it to Java. In latest rendition, let's say last 5, 6, 7, however many years, they added this kind of a loop in Java. I don't know if they added it in C. Maybe some of you know. Okay, so here's the syntax of the simplest C statement. So here, let's say we created a string. And what we want, let's say it's an apple, we want to take character one by one and print individual characters. I mean, the word itself says that, okay, somehow we have to go through it one by one. We don't know the length of it. We have to be able to repeatedly take element one by one until we come to the end. This is what this loop does. So it starts with the keyword for. You have to put that, okay? Then you need a little variable into which you can put individual elements of the string. So you name that variable anytime, any way you like. So you're going to call it char in this case. It's name that you picked. And then you have that word in. Okay, so this again is mandatory. It's a keyword in this case. And then you have your sequence, the variable that contains your sequence. In our case, the only sequences we have seen are strings so far. Later on, that can be a name of a list or arrays in other languages, okay? So what does this do, this for loop? So first time, so here, this creates a string. This line creates a string. We come to this line here. This for loop will, every time you execute it, first time you execute it, it's going to take the first character from a string name and place it in this variable that you named. Okay, so the first time we encounter for, we are going to take the first character, which is capital A, and place it in for, and then we're going to enter the body of the loop. And you know that you embody in the loop because it's indented in the loop. So we enter the body of the loop, and we print that character is going to print A. Okay, whenever you run a loop, you always keep on returning back to the beginning of the loop until some event happens. So let me tell you what is the event that happens in this case. So you come back to the beginning of the for loop, you see, is there another character after capital I? The answer is yes, so you take it. So now character is P. And you enter the loop, and you do that on and on until eventually, once when you return back, let's say you had the last letter, you printed E, you come back, and you say, I want to take the next character after E, and you realize there's no more characters after E. And then only you leave a for loop and you continue with the program. Okay? So let's see that actually, let's see basically equivalent statement to that. And I'm going to show you. All right, so here. So let's do exactly that. So basically, just to demonstrate, let's say I have something, a word, I don't know what word to put. Something boring like this. Okay, and we say, I want to, so here's what I want you to do. You take character one by one, the letters of this word, you print a letter, then some stars. The next letter, then some stars. Okay, the word it says that you have to loop. You have to go through the elements of the or characters of a string. So I need a for loop. You pick your own variable, the one that is going to hold individual characters. Okay, to demonstrate it really can be anything. I'm going to use a silly name. Normally you should use a meaningful name like a char for a character. Then a word in. Remember those two keywords are there. By the way, here is a slide with the syntax. Here's your syntax of the for loop. You have a word for mandatory, word in mandatory. The first thing is a variable, the thing that is going to hold individual characters. And the last thing is a sequence. Again, it can be anything. It can be a string, it can be a list, and so on. And then you have an indented block. So you have a body of the for loop. It can be a million lines of code. You can be repeating. It can be arbitrarily complex. And finally, outside of the for loop, this is where the program continues. So that's a syntax description of the simplest form of the loop. This is called for looping over the elements of a string. You're not looping over the position or indices. Okay? Okay, so here, where are we? I'm right there. Okay, so I want to say for. I'm going to have my own variable there, and then what is my sequence? It's actually a string. Okay, so this variable blah will call the individual character of this word, of this string that I called word, and I said I want to print these individual characters, then I want to print some stars in between. I don't know, it's some silly example. Okay, so let's see if that worked. Run. There you go. Okay, it worked. But here's something that is really useful to see. Again, even for this, for those who the loops are new or anything, this is such a useful thing. I'm going to do something shorter. I don't want to loop through this much more. Okay, so let's visualize what's happening. So you have, here's a variable. You're going to store word 1 in it. You see that? You see they even represent, this is a variable that represents what's in a variable in a bucket. There is a reason they draw this rectangle here. Okay, we encounter a for loop. So what did we say? You look at this string and assign the first character, first time you encounter it, into this variable blah. You will see that that creates a variable. Remember in Python you actually create a variable by assigning something to it, but this de facto does that. It takes the first letter here and assigns it to blah. That creates variable blah, and now we are inside of the body of this function, and it says print blah is going to print, print some stars is going to print some stars, but pay attention what's going to happen to red line. It always goes back to the beginning of the loop. Where is the beginning of the loop? It's here, okay? So it's going to print the stars and go back to the beginning of the loop. Now it says put in this variable blah the next character. It's n. So you will see here now that blah will change into n. Then you print n, you print stars, go back. Take the next one. It's e. You will see that blah will change into e. You print it, you print star. Oh, I clicked it ahead of time. What I wanted to ask, before I did that, let me just do something here. Okay, I'm going to run through this. Okay, here. So E, so it just took E, okay, and printed the last letter of that string. And I was about to ask you, but I clicked on it too fast. what is the next, where is the place that the red line is going to move? So in the previous class, because that's the end of the string, basically everybody said line 6. But the thing is, Python actually just doesn't know that you arrived at the end. It's not checking it ahead of time. So it goes back to for loop. It goes back. It always goes back to the beginning until the terminating condition happens. So right now it says, okay, I want to take a next character after E. It's only now it realized there is nothing after E. Therefore, it's now that leaves this loop. So it skips now the body of the function and continues where the program continues here. Okay? So even for those who know the loops, there's something to learn by running examples in this visualizer. Okay, so this type of a loop, the simplest one, looping over the elements of a sequence, works by some variable. You have this variable here, in this case I call it blah, where you simply repeatedly put elements of the sequence one by one until you come to the end of the sequence. Okay, that's the syntax of that one. Okay, so let's actually solve some problem before the end of the class. I will keep this, I don't know why I opened this one. Yeah. Oh, sorry, I was doing. All right, so we want to solve a problem. So look at this, what we did here. You can imagine that this solves the problem. Okay, here's a solution to this. I coded this before asking you a problem. But let's say somebody gave you a problem, if nothing else, a lab or assignment that says, okay, given a string, write a program that's going to print characters in that string one by one separated by stars. Okay, so here would be the solution to that problem. Let's say now we want to do something else. I say, okay, I give you a string, and you don't print all the characters separated by stars. I want you to only print vowels. Okay? So let's do that. Let's write a function. I'm going to do it as a function now, not in the main, although I will keep this here just as a reminder of the syntax. So let's write a function. Input to a function is going to be some string. Somebody's going to give me a string, and I want function to print the vowels. That you go through the string and you print every time you encounter a vowel. So def, I'm going to call it print vowel. All right, so first thing first, how many input parameters do I have? How many variables do I need to store input that the user is giving me? That I call, right, it's a string, and I'm going to give it, this time I'm going to try to use reasonable names, okay? Okay. So before we solve the problem, let's do a type contract because it seems to be causing a confusion. Type contract, you should always think of a function as a black box, okay? It is a black box, right? You talked about in. In is actually a function. It's just hidden for you that it's function. But when you're using a function, we run a help pages to figure out how do I run this function. That's what a type contract is for. The function is a black box. It has some parameters. You are just for these parameters, the inside of it is a black box. You're just telling the user, if you give me, let's say it says 3 parameters, tell me what type of data do you accept for these 3 parameters. And your type contract may say, if you give me 3 strings, I promise I'll give you something reasonable back, okay? Because let's say I'm expecting a string and you give me a Boolean, true, then your program may crash because that's not what you expected, right? So in this case, we are telling the user, if you give me a string, I will do something, right? So we have seen from my description that S is, that's the first part. So when you're designing a function, it really is a black box for the user. The user knows what data it gave you in the parentheses. So it has, this is what type contract says. The data that is in the parentheses, tell me what type of data you want. And then your user sees the output. In other words, user expects does the function return anything? That's a return type. If the function returns something, tell me what type of data it returns, or put none if it doesn't return anything. Okay? So let's go through this. This function, I said, I want a function that is an input. You give it a string, and this function needs to print the vowels from this string. Okay, so the input parameter S is a string. What is a return type? What type of data does this function return? So we are going to, the function needs to print all the vowels from a string. What is a return type? What does the function return? Okay, I heard a million strings. The answer is not a string. The function doesn't return anything. Just listen, I mean, this is very important even for your assignment. And it actually goes back to the lesson print versus return. If you just print a result, you're actually not returning a value. You can not multiply that value with something because it was only printed and not returned. And my description, when I was describing to you what your function should do, all it says is it should print the vowels. That's it. Okay, so we solved that, but you don't return anything. Okay? Nobody asked you to return anything. The description didn't say to return anything. And if you don't put a return statement, which you won't because nobody asked you to put, Python is going to put the one for you. It's going to be return none because the function doesn't return anything. Okay, so this function here, what does it return? Nothing. It prints stuff, but it doesn't return any value. Okay, I could have asked you to, and I will actually next time because here we have only an example. I could have asked you something else. I could have said, okay, you write a function, I give you a string, and your function creates a new string containing only the vowels from the original string. And you should return that new string. Okay, then the return type would be string. Because at the end, after you create a new string with only vowels, you would put return that new string. So in that case, you would be returning a string. Okay? So let's solve that. This one, no, not that, this. Okay, so let's remember what we have to do. I'm given a string. I want you to print vowels of that string. Okay, each vowel that is in the string, I will want you to print them one by one, separate by stars. Okay, but in order to solve this problem, the word itself, it's very obvious that you have to look at every character, right? But that means you need a loop. You need a loop to loop through the characters of a string. And you have seen this, how to do this, what the syntax is. We do for, and now put a variable name, the one that is going to hold individual elements of a string. Reasonable name for that is char, because elements of the string are characters, right? And then you have to put word in, and then the string that you will loop over. Well, the name of the string is S. That's the one that the user will give us something for. Okay. So before we had this, right? Before we had that. Well, except in this case, the variable is not called blah, it's called char. That's when we were printing every character. But now I don't want to print every character. I want to test something, and if it's true, I want to look at this character, and if it's a vowel, only then I want to print it. So what do I need if I need some condition to be true in order for action to happen? You need if statement, right? So we do if. So what we want to do if we want to test if this char, and I'm going to put this like this, is a vowel. We're going to see how to test that. How do you write that condition? Okay, and we are basically done once we figure out how to test this. So here we have a character that we took from this string, and we have to test if it's a vowel. How do we do that? Yeah? Okay. Okay, very good. But normally, especially those who program before, you get this. Okay, so let me go give you a typical solution, and it's also a completely okay solution. You write a compound Boolean expression. You say, okay, what are the vowels? By the way, even that is not clear because for me, I thought vowels are only I don't know how to A, E, O, U. But apparently some people say that Y is a vowel in English. Is it? Some. What do you mean sometimes? Okay, so because of this sometimes, I'm going to disqualify it. For purpose of my program, I will disqualify A. It's only going to be this 5, okay? So you would normally want, okay, I'm going to print it if it's one of these IA. So you're going to, okay, if character is equal to A, or character, and then or character is equal to equal to A, or character is equal to AE. Okay, and there's two more. I don't want to type it. This is how you would do it in other programming languages. Okay? You know, you are, if you A or E or I or O or U, if one of them is true, that means you eval, and then you execute the body of for loop. Otherwise, you skip. You return back to the beginning of the for loop and take an next character because you would get false for there. Okay. But in Python, as a student suggested, whose name I really should remember because it answers a lot of questions, there's such a cool way to do it using a hammer that we've learned. And here, remember that in Python, you can ask, is a character one of these? Is this thing one of these? But that means just tell me, is this char inside of this string? A, E, I, O, U. Look at that. Isn't that great? I love it. Okay? So you can just ask that. Is it one of these characters? If the answer is true, then you type it. Otherwise, you don't. So let's just run this one more time. Not one more. Let's run this to make sure it really is working. So, okay, I'm going to remove this actually. I don't need that. So let's do that. You're left with 30 seconds. I want to show you something else. Print, vowels, I don't know, kiwi. All right. It's printing vowels. But what about this? Print, vowels. Okay, so we need to fix it a bit. How do we fix this? Yeah? Okay, so I've seen two ways to fix it. One is I can just add capitals here. A, E, I, O, U. That fixes it. Another one is the lower thing that you've seen. You can say, instead of asking is char is there, first make it a lowercase letter. Okay? And then run it. Oh, except that I entered this and I don't even know how. All right, so now it's working. Okay, so see you Monday. Don't forget to submit your assignment.